What's up guys, welcome back to your fourth beginner C programming tutorial, and here's today's agenda. We're going to be talking about various data types and their corresponding sizes. What are the data types, how to use them in Codeblock, and why we use them. To conclude the presentation, we'll write our second program and review the code as well. Okay, so let's begin. Here are the various data types outlined on the very first column, followed by their description for each one of them, as well as their size and ranges. So in our previous tutorials, we've been talking about integers. These are just whole numbers, but I also introduced you to the float data type, which are numbers with decimals, and they could hold up to 7 digits. Now if 7 digits is not enough, you want more digits, you could use what we call a double. Basically a double is just a more precise floating number. These could hold up to 15 digits. Of course, there's some compromise behind that, is that it occupies more memory. You see 8 bytes versus 4 bytes right above. Okay. I'll also introduce you to the Char data type, which is short for characters. These are all the characters you see on your keyboard. Their range are from -128 to 127. On the positive side, 0 to 255. Now if you're a really crazy scientist that's going to work for NASA in the future, you want a range that's beyond these specified range, what you have to do is put the keyword long in front of int. Basically it will give you more flexibility to use values beyond these ranges. I'll show you right now in Codeblock, don't worry about it. So go ahead, open up Codeblock and create a new project. Console, this guy of course, and let me call this guy lecture for data types. Alright, go ahead, next, finish. Alright, let's expand this guy real quick. Okay, so let's start declaring and initializing our values. I'm gonna play with integers first, so int, I'm gonna call it my int. Let it be, let's say 9, and then int my int 2, let it be 2. Okay, now let's declare some floats. Float my float 17.0 decimal. Okay, and my float 2, let's say 2.5. Okay, now let's perform some mathematical operations with these two integers first, and we see what happens. Go ahead and printf. Let's double quotes and do that. %i stands for integer, and fill this %i with some mathematical operations. I'm gonna do division and see what happens. Normally we anticipate the answer to be 4.5 because 9 divided by 2 is 4.5 obviously, but notice both of these variables are integers, and we said integers only store whole numbers. They don't hold decimal values, so you won't get 4.5. Basically, if both of your variables are integers, your result will become an integer as well. So the fractional portion gets truncated and thrown away. So your answer will be 4 instead of 4.5. What I mean by is the 0.5 gets thrown away because your result is an int, and int only holds whole numbers. So if you run that in Codeblock, you'll see that you get a 4 as your answer. Here it is, 4. Oops, let me just go to the next line so you don't get conflict with the hello world statement. See, as we see, it's 4. So if you want the correct answer, one of your variable must be a floating type. Basically what happens is that the non-floating number will get temporarily converted to a floating number. Then you'll have 2 floating numbers, and then the division or multiplication gets executed. So in that case, if you do 17.0, which is a floating number, and divided by 2, which is a non-floating number, the non-floating number will get temporarily converted to a floating number, and then the division is performed in this case, and you get 8.5. So let's prove that in Codeblock real quick. So I'm gonna change this. I'm gonna do 17, which is a floating type, divided by 2, which is an integer. Okay, so 17 is my float divided by my int 2. And then let me delete this statement real quick. And now, since your result is a floating type, you no longer can do %i. You have to change this to %f, as we showed in the previous tutorial. And there we go. We got 8.5 right here. Notice there's so many decimal digits right after. So you can actually format the amount of decimal. How you do it is, if you want 3 decimal places after the dot, just go ahead and put period dot 3 and then run this guy. So now you should get like this, 3.500, which is 3 decimal places after the period. Okay, so that's with the floating number. Of course, if you do 2 floating numbers, your result is also going to be a floating number as well. So if you do 17 divided by 2.5, you get a floating for sure. We could prove that right now. Was it my float 2, right? Okay, 6.800. So as we anticipate, so that's how you use the floating type versus the int type. Just be sure whenever you carry out some mathematical operations in the future that involve decimal places, be sure to declare one of your variable to be a floating type. Okay, and of course you don't want to put %i, you want to use %f. Okay, just keep that in mind, because sometimes if you do this right now, let's say put I, your answer, you won't get an answer. Basically you get some weird numbers here, see, because your answer here, it's a floating, and you put in %i, which stands for integer, and that's not correct. Okay, so change this guy back, run it again. There we go. Cool, huh? Now if you want a more precise floating number, remember you said I said you could use the data type double. So double, I'm gonna call it my double. Okay, you don't actually have to remember this chart here, the size. I'll show you how you can find the size for each one of these guys. So there's a int, there's a float, there's a double. I'm gonna copy and print out 3 statements to show the size for all 3 of them. Okay, let me go ahead and %i, because it involves size. Size are just integers, number, whole values. So in English, if you want to find the size of something, you would ask what's the size of that thing. So similarly in programming, it's very simple. Put size of and a parenthesis. I'm gonna do my int, and then this guy I'm gonna change it to size of my float. Okay, and then this guy, same thing, size of my double. Okay, so once I print this out, I'm gonna get the size of an integer. Once I print this guy out, I'm gonna get the size of a floating type. And the last guy here, it prints out the size of a double. So go ahead and run that, and you see here it is. The answer is 4, which we said for integers. These are bytes, by the way. 1 byte is 8 binary bits, so just keep that in mind. So integer 4 bytes, floating 4 bytes, and remember we said double, it holds more digits than the float. That's why the downside is that it consumes more memory space. Notice it's 8 bytes, it's double of the float. Okay, now let's talk about the long keyword. To explain that, let's go back to PowerPoint slide real quick. We said long gives you more flexibility to specify your number outside of these given range. So for instance, integers can only go from minus 2.1 billion to 2.1 billion. And that's for signed. And for unsigned, which accounts for a positive range, 0 to 4.3 billion. So let's go ahead and, by the way, in C program, by default, your numbers are given as signed, so it accounts for both positive and negative. So if you want unsigned number, which only accounts for the positive range, you could just go ahead and type in the word unsigned in front of your integers. That's how you use that to get a more broader positive range. Okay, so let me go ahead and delete that real quick. Let me show you something. So we said that default the values are signed, which goes from the maximum value to what, to 2.15 billion. So let me use this value and see if it's actually within the specified limit. So I'm gonna go ahead and use this number here. I'm gonna copy this number and use it on Codeblock, and I'm gonna declare my int 3, and now I'm gonna use that maximum value, and let me delete these guys. Okay, I'm gonna print out my int 3. So let's go ahead and see if it actually prints out this maximum number. Okay, as we see, it's right here on the console. It actually displays this maximum value. So that's true. So what happens if you want to use a more bigger range than this? So if I go to 3 billion, what happens is that you get a funky answer because it exceeds that limit for an integer. See that? You get some weird number every time you run it. See? So if you really want to use a broader range, let's say all the way up to 9 billion, all you have to do is insert this keyword in front of your data type. You could actually put another one if you like. So you see long int. Now to account for the print, you just have to put LLI, which is short for long int. So your answer prints out as follow here. The downside, of course, is the memory. So let's check the size of the long. So put another one, and you want to delete these because the size is in bytes, and bytes are integers. So before, you notice that the integer here is 4 bytes. What happens when you put the keyword long in front of it? Well, it becomes 8 bytes. Now occupies more space since it could store more values in that variable. Okay, now let me show you the char data type. Let me delete all these. To use that char, all you gotta do is put the keyword char and the variable name. I'm gonna call it my char. Right after the equal sign, single quotes, and inside the single quote is whatever character you're gonna put. So let me put B and semicolon. Now to print this character, all you gotta do is use printf command. Inside the double quotes, instead of %i or %f, you have to put %c, which is short for character, followed by the character name. Go ahead, print this guy, and you should see letter B. Now I must remind you, the char data type are represented by whole values, hence integers. Their ranges are specified here. You can find them by googling ASCII table. You'll see a bunch of characters on that table. For instance, the capital A, it's represented by the value 65, capital B 66, which I'll show you right now. Change it to I, you see 66 here, like this. Okay, so due to time, I have to conclude the presentation. Sucks that we didn't get to program in this tutorial, but in next tutorial we're going to do a bunch of programs just to reinforce all the concepts we learned up to so far. So don't forget to subscribe. Thank you very much. See you in the next tutorial. Bye.